Hi everyone, welcome back to Study with Sri. In this video, we learn one of the most important integration patterns in pure mathematics, which is the integration of 1 over x squared plus a squared. If you master this, you can handle a lot of exam integrals easily, especially the ones that look confusing at first. First remember, integration is reverse differentiation. Integration is reverse differentiation. You should remember this whenever you are approaching an integration question. These are fundamentals, but most of us, we are not good at the fundamentals. If we are good at the fundamentals, we can approach any complex questions. So whenever you are doing some questions, if you are not doing properly, try to understand you are not clear at your fundamentals. Try to rectify the issues with your fundamentals, then everything will be easy. From the previous video, we have learned the derivative of arctan x, the derivative of arctan x with respect to x is 1 over 1 plus x squared. So that immediately tells us the reverse fact. Which is the integration of 1 over 1 plus x squared is equals tan inverse x plus c. But if you want to clearly understand even more, simply cross multiply. The dx gonna be multiplied the other side, which is the derivative of arctan x is 1 over 1 plus x squared dx. Let me integrate either side. This is 1 over 1 plus x squared dx. Remember, d of arctan x means you integrate the d of arctan x, the small portions of the tan inverse x, and if you integrate them, then it would be tan inverse x plus c. That's why we got this form. So whenever you see this, that immediately tells us the reverse fact is true. This is arctan. So whenever you see the 1 plus x squared in the denominator, your brain should shout, this is arctan. Okay. Now let's say, now the exams often give you x squared plus a squared instead of x squared plus 1. The exams often gives you x squared plus a squared instead of x squared plus 1. So the key result is, let me write the key result, the integral of 1 over x squared plus a squared is equals 1 over a tan inverse x over a plus c. So the key result is the integral of 1 over x squared plus a squared dx is equals to 1 over a tan inverse x over a plus c. Let me explain why there is a 1 over a there in a very simple way. Think, if inside arctan we have x over a. Inside the arctan we have x over a. Then the inside is u. So u is x over a. If you see the previous video, you can understand. The u is x over a. And the du over dx is the derivative of u with respect to x is 1 over a. If you don't get it properly, see here. If u is x over a is 1 over a into x. So the derivative of u with respect to x is 1 over a. So you can understand, if inside arctan we have a x over a, then inside is u. This inside is u, and du over dx is 1 over a. That 1 over a is exactly why the answer is 1 over a outside. That 1 over a is exactly why the answer is 1 over a outside. So it's basically chain rule in reverse. That basically the chain rule in reverse. Try to understand very carefully. The tan inverse u, this x over u is u, the x over a is u, the derivative of u with respect to x is 1 over a. So that's why you have a 1 over a in the outside the answer. So it's basically the chain rule in reverse. So let's try to understand how we are going to approach these questions every time. First, is it of the form x squared plus constant? Is it of the form x squared plus constant? If so, then we can think it is arctan form. Is it of the form x squared plus constant, then it should be arctan form. So make it match exactly x squared a squared. So the first step, first see, is it of the form x squared plus constant, then it should be arctan form. The second step, make it match exactly x squared plus a squared. Sometimes you must factor out a number or else rewrite it so it looks like x squared plus a squared. Then you apply the third step, you're gonna apply the arctan formula. The third, you're gonna apply arctan formula. What is the arctan formula? The integral of 1 over x squared plus a squared is equals to 1 over a arctan x over a plus c. So the idea, how to recognize it quickly and how you approach these questions every time. First, you see, is the denominator in the form of x squared plus constant form? Then okay, it should be a arctan. Second, try to make it match exactly x squared plus a squared form. Sometimes you should be factor out a number, or else you should be rewriting so it look like x squared plus a squared. Then apply the arctan formula. If it's defined integration, after you integrate, substitute the limits carefully. If it is a definite integral, then after you integrate, substitute the limits carefully. So let's see some examples in the same way. So we're going to approach these 3 steps and try to approach some of the questions in this way. So let's see. Let's try to find the integral of 1 over x squared plus 25 dx. So now we already know our checklist. What is the step? The first, you have to think whether it is in x squared plus constant form. Yes, it is the denominator is x squared plus constant form. So the first checklist is fulfilled. Now, if you compare, this is x squared, this is constant. So this constant, the a squared must be 25. So you can see a is 5. Now the second step, apply the formula. What are you going to do? 1 over x squared plus 25 It is, your A is 1 over 5 arctan x over your A is 5 plus C. A very simple idea. So this is a very simple idea. So you just first check whether it is x squared plus constant form in the denominator. Obviously it should be arctan. Then you're going to apply the formula, simple as that. So if you're fine with this, let's see one more example. So let's find 1 over 2x squared plus 3 form into dx. So here you try to understand whether it is x squared plus constant form. So if you see here, first let me do some small manipulation here. 1 over, to make it x squared plus constant form, let me factorize, let me get the 2 out. It would be x squared plus 3 by 2 dx. Wow. Now this is x squared plus constant form. If it is x squared constant form, then it is arctan formula. Now you bring this 1 by 2 out. 1 by 2 integral of 1 over x squared plus 3 by 2 dx. Now the x squared is okay, and we have to identify this is a squared. If the a squared is 3 by 2, a should be the plus or minus square root of 3 by 2. Now let's apply the formula. What's our formula? The integral of 1 over x squared plus a squared dx is equals to 1 over tan inverse x over a plus c. So 1 over for a, so if you substitute 1 over a, so we already have this 2 out, we have already this 1 over a out, right? So you have already 1 over 2 out, so 1 over 2. Now into 1 over a, for 1 over a, 1 over root 3 by 2, root 3 by 2, so the reciprocal would be root 2 by 3, root 2 by 3. The reciprocal is root 2 by 3, root 2 by 3 into tan inverse x over a, x over a. So that also, if you write it in the reciprocal form, it should be x into root 2 by 3 plus c. So your final answer would be, so if you know this, your final answer would be, let me write the answer here, somewhere here. So your final answer, 1 over 2 root 2 by 3 tan inverse x root 2 by root 3, or else root 2 3 by root 2 over 3 plus c. A very simple idea. So the intuition is, first make it look like x squared plus a squared. Factorizing is the key. Then you can unlock the idea of arctan, and it would be very, very simple. And let's try one more question before we wind up this video to check whether we are more clear. And let's try a definite integral. So let's try to find the exact value, the integral of, in the lower limit 0, the upper bound is 2, 1 over x squared plus 4 dx. What's our first step? Whether the denominator is x squared plus constant form. Yes, it is a constant form. So our first step is, first checklist is fulfilled. Now you identify the a squared. Your a squared is 4, so a must be 2. Now let's integrate using the formula 2 to 0. 1 over x squared plus 4 dx, we can write 1 over, For the a, you can write 2 tan inverse x over 2 plus c. Now after we integrated, this is a definite integral, so you're going to apply the limits from 0 to 2. So you're going to apply the limits from 0 to 2. So it would be of tan inverse x by 2, upper bound is 2 and the lower bound is 0. Upper limit is 2 and lower limit is 0. So if you substitute x for the 2, then it would be, if the x is 2 for the upper limit, it would be of tan inverse 2 by 2 is 1, and then if you substitute x 0, it's of tan inverse 0. Now we know tan inverse 1 is pi by 4, tan inverse 0 is 0. So tan inverse 0 is 0, tan inverse 1 is pi by 4. So our final answer would be, let me write the answer here, of into pi by 4 minus 0. So the final answer, pi by 8. So see, what a simple approach. So you must understand this kind of a very simple questions. So if you want to approach these questions, if you want to try some complex questions, you must understand the fundamental. You should never just memorize the formula, because nowadays it is mostly exam based. If it is just an exam based, you tend to memorize the formulas, so you won't be able to think. So you should understand the derivation clearly, and you should know why you are writing this formula. And if you are writing this, if you know why you are writing that formula, even if there are questions completely different, so you can think out of the box only if you know the fundamentals clearly. So before the next video, let me give 3 more questions, and you can try those questions and you can write your answers in the comment section. So let's see. The integral of 1 over x squared plus 9, and the another one is 1 over 5x squared plus 20. You can try one more question, which is the definite integral between 0 to 1 over x squared plus 1. So try this question. The checklist is, first always remember, integral is the reverse of differentiation. In this type of integration, first try to identify the denominator in the form of x squared plus constant, and if you know the constant, then find out the a, and you know the general formula, apply it. Whatever the difficult questions, you should be easily able to do. And if you have any other difficult questions, you can post it in the comment, and then I can make a small videos to explain them. And in the next video, let's talk about another further differentiation or else further integral part.